Okay, in this lesson we will get our first glance at Coulomb's law, which gives you the relationship between the electrostatic force between point charges. So let us consider 2 point charges, Q1 and Q2, separated by a distance r in free space or vacuum. Free space and vacuum, they are the same. Now, because both Q1 and Q2 are positive, they experience a repulsive force. So you will have F1, which is the repulsive force, on Q1, and F2 is the repulsive force on Q2. So by Newton's third law, we can very well say that the magnitude of F1 is equal to magnitude of F2. Let it be F. Of course, F1 and F2 will be in opposite directions. So if we consider, or if we take the magnitudes of F1 and F2 as F, then by Coulomb's law, this electrostatic force between the charges is proportional to the product of the charges, Q1, Q2, and inversely proportional to the square of the distance between them. Now, in case of free space, or even in case of air, we can write F is equal to 1 upon 4 pi epsilon naught Q1 Q2 over R square. So here the proportionality constant has been written as 1 upon 4 pi epsilon naught. So this proportionality constant in air or in free vacuum or free space is equal to, we will take it equal to in free space, 9 times 10 to the power 9. You can find out the unit. F is Newton, R square you take to the other side. Q1, Q2 comes down here, so it will be Newton meter square upon Coulomb square. So the unit will be Newton, can you see that? Newton meter square upon Coulomb square. They are not the base unit, but just a unit. So to start with, the epsilon naught is usually known as the absolute electrical permittivity of free space. That naught stands for free space. So epsilon naught is the absolute electrical permittivity of free space. This particular quantity determines the electrical behavior of different media. The value of epsilon naught, or the absolute electrical permittivity of free space, is 8.85 times 10 to the power minus 12. Again, you can find out the unit. Epsilon naught goes to the other side, F comes to the denominator here. It will be Coulomb square upon Newton meter square. Again, not in terms of base units, which we will do later. So this is the relationship of 2 point charges interacting in free space or vacuum or even in air. In other media, suppose we change the media, rather than using free space, if you use some other medium, definitely the electrostatic force will be different. Here what we have to do is epsilon naught will be replaced with epsilon, where epsilon is the absolute electrical permittivity of that particular medium. So we can write Fm. So let us write in vacuum, let us write Fv, where V stands for free space or vacuum. For the electrostatic force in a medium, let us write it as Fm. Then Fm is equal to 1 upon 4 pi epsilon Q1 Q2 upon R square. Instead of epsilon naught, you will get epsilon Q1 Q2 upon R square. Now, the value of epsilon for any media will be greater than epsilon naught. Of course, the lowest value of electrical permittivity is for free space. So, epsilon is always greater than epsilon naught, and the ratio of epsilon to epsilon naught for any medium is known as epsilon r or small letter k. The epsilon r is the term used for relative permittivity, which is just a constant, or you may say it as dielectric constant. Relative permittivity, that's what we say for epsilon r, which is actually the ratio of epsilon to epsilon naught. Or sometimes you call it as dielectric constant. Remember, dielectric constant of every medium other than free space or air is greater than 1. So what does it imply? What does it imply? Because epsilon is greater than epsilon naught for all other medium. It means that the electrostatic force between point charges will be the greatest in free space. In all other media, it will be less. Compared to free space, it will be less. For example, in case of water, the dielectric constant or relative permittivity is approximately 80. So what is the effect of this this high dielectric constant on the electrostatic force? So we can say that this epsilon will be 80 times greater than epsilon naught.